Right, so what I thought I'd do today is just quickly recap, given so many people weren't here yesterday, about what we looked at yesterday, which was really more about populations versus samples. So what's the difference between a population and a sample? And for those of you that weren't here, let's see how well you were listening. Those of you that were listening on the video, and those of you that were here, well, let's see how well you were listening in class. What is the population? And in this course, we often talk about the target population. So I guess when you hear the word target, don't be scared by that. Target population is just really what lots of people refer to as the population. So the target population is the set of, it's all members of the group, target group, under consideration. So whatever you might be interested in, that could be school uniform, whether we should change it or not, that the target population would probably be all the school students plus the parents at the school. We wouldn't be interested in surveying people from other schools necessarily, because that doesn't relate to the Perth College school uniform, and what they say probably isn't as valid as what students and parents at this school would say. So the sample is a smaller group of the target population. So sometimes we call that term a subset. So it's a smaller group of the target population that we use to make inferences of the whole population. So it would be reasonable to perhaps survey all the school students. However, if that was going to be too tedious and take too much time, we might select a smaller group. So we might select either a smaller group of each year group, or we might just randomly select students and parents off the school roll. Regardless, that smaller group is called a sample. So that's the difference between them. The other thing we talked about yesterday is that it might be impractical to deal with the entire population. If we're interested in where all Year 12 students in Australia, an opinion about them, then that is probably too large a sample. We might not be able to access. Yesterday we did one, I think I talked about sharks in the Indian Ocean. So something along that. This one's example is blue whales in the Pacific Ocean. You can't access the population. And so we might take samples around the Pacific Ocean to see. The data might be destructive. So yesterday we talked about taking a blood test. You don't take all of your blood. We only take a sample of your blood, because otherwise you wouldn't survive. So sometimes we're forced to take samples. Other times we take a sample because it's easier, it's cheaper. And yesterday we went through some of those advantages and disadvantages. So if we take a sample, it does help us make statements about the property of the population, but we just need to make sure that we are not taking a biased sample. So if I was interested in what students felt about maths, I gave this example yesterday, if I just surveyed this class, then that would be a biased sample, because you would all have probably similar opinions. So generally quicker and cheaper taking a sample, but we just need to be careful that we want the sample to be representative of the population. That's the important thing. And there's a lot of money and a lot of research, and you've got special people that deal with working out what and who the best people should be selected for a sample. Things we do consider is the size and the selection. So the focus today is going to look at that. Yesterday we talked more about what the difference between a sample and a population and that target population is. And I'd use this term bias. We want to make sure it's free from unwanted bias as possible. Yesterday I didn't talk about how big the sample should be, but I thought it relevant in what we're looking at today. So the sample should be large enough to get an idea of what is going on or what people's opinions might be. So if you only ask 1 or 2 people, that's really not going to give you a good gauge. So lots of books talk about having at least 30 samples. And if you can, have more, but certainly no less than 30 to give you at least a good gauge of what people's opinions or ideas might be. In general, there is a formal rule. It's probably a bit beyond this course, but I thought I'd just put it in there because it is something that we do teach. If you've got N members, so however many that might be, then we want at least the square root of N members, or 30, whichever is greater. So for example, if there's 100 people that you want to survey in the target population, then the square root of 100 is 10. So that's not enough. So we would then say, well, we've got to survey 30. So we get a good range of opinions and ideas. Whereas if we had 10,000 people, then the square root of 10,000 is 100. So in a population of 10,000, you would try and survey at least 100 to try and get the information you require. All right, let's have a look at this first example. Just talking a little bit about bias. We didn't talk about that so much yesterday. Why is there bias, or is there bias in this particular scenario? I'll let you read it. Where everyone has equal chance of being selected. Is this a good method of getting information about whether the local library is catering to the needs of the town's residents? What do we think? Do we think this is a good way to get that information? Handing out a questionnaire to people that come to the library during the week? Yes? No bias in that? All right. Yes, there is actually. So let's think about this. We want to know, and I've underlined, the town's residents. Now, the people that frequent the library, don't you think those people would probably feel like the library satisfied their needs because they're attending the library anyway? But the rest of the town, if they're not attending the library, there might be a reason as to why. Maybe it's not catering for their needs. And so this is actually an example of a bias sample because they're already surveying people that frequent the library rather than a random selection of people across the town. So how could we minimise that bias? How could we possibly select people across the town, not just those that already come to the library anyway? What could we do? If we're talking adults, every adult is on a particular electoral roll. So you could select someone off the electoral roll or select people off the electoral roll, and that is probably the best way to get the names of the people that live in the town, firstly, and then from there you can randomly select. And today we're going to talk about a couple of methods, and that and moving on to next lesson as well, in terms of selecting, how to select your sample. So we've got this roll, we've got a list of all these people that live in the town. How can we then select 100 or 1,000, depending on how many in the town, at least 30 people from that roll? And like I said, that's what we're going to look at today. We just need to make sure that everyone has an equal chance of being chosen. So on a list, there's an equal chance of being chosen. And the first type of sampling we're going to look at is what we call simple random sampling. So there's no pattern in a simple random sample. Every member of the population has an equal chance of being included. Where could simple random sampling occur? So I want you to think about an example where that could occur. How could we do it? How could we randomly select a group of people? It could be the town, or if we want to make it in a context that might be more familiar to us, let's say we want to survey Year 12 students at PC about the ball. But we haven't got time to go ahead and go and interview everyone, so we're going to randomly select 30 people. How could we do that using what we call a simple random sample? What do you think we could do? I'll let you think about that. Write an idea down and then we'll share them. So you could have the role, why is this not writing now? Role of the Year 12 cohort. So we need a list of that Year 12 cohort. And then from that list, you can use a random number generator to select 30 numbers. And I'm going to show you how to do that in a minute, or we're going to research how to do that in a moment. And randomly select 30 numbers, and then those 30 numbers will account to the 30 students. Each student should be numbered. Let's say there's 150 students, number 1 to 150, and we're going to select 30 of them. That's one way. And that uses a bit of technology. Without technology, what could we do? So we could snip the list of names, each name individually, put them all in a bowl or a hat, mix it all through, and then randomly pull out 30 names. So that is a very simple example of a simple random sampling method. Okay.